Welcome, everyone. My name is Jamil Guevara. I want to first thank you for watching this video. And if you like this video, I want you to please subscribe to my channel and click like on this video and make comments on the comment section below of this video. In addition to watching this video, I want you to do something for me. I want you to please apply the knowledge that you gain from this video at your job. I want you to please uh, apply this knowledge so that you can get a promotion, so that you can actually get um, a pay raise. I don't want you to watch this video just for the sake of watching. I want you to apply it at your job, get a promotion, get a pay raise. That's what I want from you. I want the best for you, okay? So let's begin our journey, okay? So in this video lesson, you will learn a popular machine learning algorithm. It is called decision trees. You will use this classification algorithm to build a model from the historical data of patients and their responses to different medication. Then you use the trained decision tree to predict the kind of medication that the patient should be taking. So this decision tree is very important because you're going to be building a decision tree, and then you're going to be telling the patient what kind of drug is going to work for them based on the decision tree model. So very important. So let's begin our journey. As you always know, the first step in building any machine learning model is to import our libraries. We're going to be importing NumPy as MP. We're going to be importing pandas, okay, as PD. And we're going to be importing sklearn dot tree import decision. Let's see, decision classifier. By the way, when you use Jupyter Lab, if you hit the tab button, it gives you autofill. It makes your life easy. So I'm going to be using the tab button to autofill for me because it makes my life a lot easier when it's autofill. Okay. So now that we have imported our libraries, it is time to import a dataset. And I'm going to import my dataset into the variable called my data. So we're going to use Panda to read our data, read a CSV file. Okay. We're going to be importing drug 200 CSV and delimiter. Let me get that delimiter. Come on. Let's run the code. Okay. So far, so good. I don't know about you, but I always like to run my code just to make sure that there are no errors in my code. I just want to make sure that there are no errors at all. Okay. Okay. So let's look at our data. I like to always see the first four rows of my data set. So I'm going to see my first four rows of my data set. And here it is. Here are the variables: age, sex, blood pressure, cholesterol, Na2K, and the drug. Okay, so far so good. So now let's declare the following variable: X as the features matrix and Y as the response variable or response vector, okay? So let's do that right now. Okay, so I like to scroll up. Maybe you guys want to see your data, but I like to scroll up because it makes it neater for me, okay? So let's do this. X idea. That's where our features are stored. H, 6, blood pressure, cholesterol, 8, 2, okay, values. Let's run that code. Okay, so far so good. I always like to see what's in my data set. So let's do that. Let's run the code, see what's in it. Okay, there it is. We got the age, gender, blood pressure, and of course we have the cholesterol and Na2K. Okay, so far so good, everybody. Everybody's doing so well so far. I'm really impressed by you. You guys are doing such an amazing job. Okay, so I don't know if you noticed, but as you may have figured out, some features in this dataset are categorical, such as sex and blood pressure. Unfortunately, sklearn decision trees does not handle categorical variables. So we still need to convert these features to numerical values. And we can use sklearn pre-processing to convert the categorical variables into dummy indicator variables. So we are going to be doing that, just that right now. So let's begin our journey. So we're going to be first converting the sex categorical variable into dummy variable. So let's do that. So we're going to use sklearn import pre-processing. Excellent. And this is going to be our sex variable pre-processing. Excellent. Labor encoder. Okay. And of course x and x transform. Okay, so far so good. Let's run the code. Okay, there's an error here. Let's see where's the labor is not fit again. Oh yeah. Sorry guys. I made a mistake here. Okay, so let me see. It's not fitted yet. We need to fit the label. And, and the machine is actually correct. It needs to be fit. Okay. I made a little mistake there. Okay guys. Let's fit our data. Email. So that should fix the problem. Let's run the code. Yeah. Sorry, I apologize for that, guys. I need to fit the data. So now that we have transformed the sex categorical variable into dummy variable, let's move on to the blood pressure. Okay, guys? Okay, so let's do the same thing. Blood pressure, pre-processing, okay, LE, pressure. Let's fit our data. Let's not do what we did before. Okay. Oh, oh, please don't do that, please. Okay. Low, normal, high. Right? That's high blood pressure. Healthy blood pressure. You can transform it. Blood transform, transform, transform this data. Let's run the code. Let's make sure there are no errors. There's some error module object not callable. Give me a second. Let's see what I did wrong here. Pre-processing label quarter. There it is. Let's do it again. Excellent. So far, so good, everybody. So we have converted the categorical variable of sex into dummy variable. So far, we converted the blood pressure categorical variable into dummy variables. And we need to convert one more categorical variable into dummy variable. That's cholesterol. So let's do that. Cholesterol. Preprocessing. Excellent. Label order. Excellent. Let's continue. Elite cholesterol. We're gonna put our data into there. We got normal. We got high. Right? And X. Our third. Elite cholesterol. Form. Let's run the code. Make sure there are no errors. Okay. Okay, no errors so far. So we've done an amazing job, guys. I'm very, very proud of you. We have converted the categorical variables of sex, blood pressure, and cholesterol into dummy variables. That's an amazing job, guys and gals. So let's continue. Let's look at, I always, like I said, I always like to look at my data. Okay? I always like to look at my data. Let's look at first 4 rows of this data that we just created. And there it is. Remember, before this data was categorical, you have female, male, male, female. Now we got 0, 1, 1, 0, 0. We used to have blood pressure, high, low, normal. Now we got different 0, 1, 1, 2. And of course, we used to have cholesterol, high, high. Now we have 0, 0, 0, 0, 0. So far we have converted the categorical variables into dummy variables. And you guys are doing an amazing job. Okay, I'm really impressed by you. Really, really impressed. So let's continue, guys and girls. Everybody, please let's continue. Now we need to fill in our target variable, okay? Okay, our target variable is y equals my data. Let's run the code. And as always, I always like to look at my data. That's the way I am, okay? I always like to look at my data. Let's look at our data. First 4 rows of the data. And there it is. It looks good so far. So far, so good, everybody. Everybody should give yourself a round of applause because you guys are doing an amazing job. So what are we doing next? We will be using a train test split on our decision tree. And we're going to be importing the train test split from sklearn, okay? So let's do that. Let's import the sklearn. So let me scroll up. So from sklearn, excellent, import train test split. Perfect. Run the code. Okay, excellent. So far, so good. So now, let's set our parameters. The train test split will return 4 different parameters, and we will name them as follow: x underscore train set, x underscore test set, y underscore train set, and y underscore test set. So let's do that, everybody. I think we're gonna do so far so good, everybody. So I'm really impressed by you. So let's do the x underscore train set, x underscore test set, the y underscore train set, y underscore test set. And of course, this is gonna have parameters, train, this, okay, okay. And here are the parameters for this size. It's gonna be 0.3. That means that 30% of the data set is gonna be used for testing the model, and 70% is gonna be used to train the model. That's what this means. And now this random state is going to be 3. Now, if you want to duplicate my results, you need to set your random state to 3. If you set your random state to any other number other than 3, then you are going to get different results than mine. Okay? That's what it means. So I'm going to set my random state to 3. And if you want to get the same results as I do, make sure you set your random state to 3. Okay? So let's run the code. All right, everybody. So far, so good. Everybody, we're doing so well, so we need to continue. Now, we need to first create an instance of the decision tree classifier called drug tree. Inside of the classifier, we need to specify the criterion entropy so we can see the information gained from each node. So let's do that, everybody. Let's do this thing right now. Let's create this instance. Okay? And it's going to be called drug tree. Decision tree classifier. Right. Equals entropy and the max. That is going to be 4. And as always, drug tree. Let's run the code. Okay. All right, guys. So everything's going excellent. So our parameter were entropy. And like I said before, the reason we're setting to entropy is because we want to see the information gained at each node. So we set it to entropy. All right. So let's continue our journey. So far, everybody's doing so well. I'm really impressed by you guys. So what are we doing next? We will fit the data with the training feature metrics in the training response vector. So let's fit our data, okay? So remember, drug tree dot fit x underscore train set y underscore train set. Let's run our code. So far, so good. Okay, so now that we've done that, let's make some prediction on the testing dataset and store it into a variable called pred tree. So let's do that. So our variable we're going to be storing this prediction is under pred tree. Okay? So drug tree dot predict x underscore test set. So let's run the code. Okay, so far so good. Now let's actually I want to see something. I want to see my prediction actually. No, actually, yeah, a mistake there, guys. It's actually type. Okay, our predictions. All right, let's continue. So now that we've done that, it is time to import the metrics from sklearn and check the accuracy of our model to see if our model is actually accurate. How accurate is it? So let's do that, everybody. So let's check the accuracy of our model. So let's do from sklearn import metrics. Okay. Import mat plot live python plot. This name is spelled ELT. Now print the decision trees um, accuracy. Metrics dot accuracy score and y underscore test z pred tree. So far so good. So let's run the code, and there it is. That's our decision tree accuracy. And so far, the decision tree accuracy is very high. We have a 98%, 0.98. Okay, that's amazing. That's actually very good. Okay, now we need to visualize our tree. So let's visualize it. We know our tree is very accurate. So let's visualize it. So I'm going to import IO, import string IO, import Py.plus, import matplotlib library image and p img, and we're going to be and of course matplotlib inline, because this is a Jupyter lab. We need to do that. So let's run it. Okay, so far so good. No errors. I want to say that I'm really impressed by you guys. You guys have done such an amazing job so far. We have created the decision tree model. We have validated the decision tree model is very accurate. And now we are at the final stage where we actually visualize the decision tree model. So let's do that, everybody. Let's visualize this decision tree model. So I'm impressed by you guys. You guys are doing such an amazing job here. I think you guys are having a future in machine learning. I do. I do. I do believe that, guys. You will do an amazing job. So keep learning. That's what I want to see. Keep learning. Don't stop learning. Keep learning in the future. Features. Feature means my data. My data. Column. Columns. 0.5. Okay, everybody. So it's an amazing journey so far. Export. Excellent. You know, I like the tab option that it autofills um, everything for you. It really makes your life easy, to be honest. I know I say that a lot, but it does. It really does, actually. I really believe that anything that makes life easy should be should be used. Okay? We're gonna be using NumPy. Okay? Unique, unique, unique function exactly. This is good. See? Not only does the tab makes it easy for you, but what it does actually helps you remember things. Helps you remember the code. I don't think anybody has the is able to remember every single part of the code. I think that sometimes we need a little bit of help. Don't you guys think that? Well, I'm sure there are gonna be people who who memorize this code and and they don't need the help. You know, they don't need help from hitting the tab button. Okay, so far so good. Let's run. Right. So far so good, everybody. Let's continue. Let's continue our journey. So graph. What kind of graph we're gonna be using? Oh yeah, pi dot. We're gonna be using pi dot plus. That's the graphing we're gonna be using. Graph for data plot. See, that's the one we're gonna be using. Dot data get value. Excellent. Get value. This one. That's it. So let's continue graph. Right. Right. PNG. We're gonna be storing as a PNG file. It's gonna be a file name. It's gonna be a PNG. I know some people like JPEG, but I prefer PNG. Uh, you can use whatever you want. Uh, I'm gonna be using a PNG. Right. I am ready. Okay. File name. Okay. I'm gonna be using plot. PLT. Remember. Figure. R size. Fixed size. It's gonna be 100, 200, fixed size, and at plt dot im show, it's going to be img interpolation years and okay, it seems like so far so good. Let's run this code. Let's hope there are no errors. Oh no, what does it say? File name drag tree png. Let's see, drag tree png. Okay, let's see. Is it okay? Features name, okay, it's not defined. Here's a features name is not defined, so I think I made a mistake here. Features name not defined. Let's see. Oh, here it is. Features name. Let's run the code one more time. Okay, features name is another features. Okay. Drag tree PNG module. Let's see. Give me a second, everybody. Trying to figure out what's the error here. Make sure there are no errors. Okay, everybody. I'm trying to see where the error is. Come on. Everything looks fine. Let me run the code one more time. Okay, there it is. Okay, it's going to take a while to generate. Oh, here it is. Here's the image. All right. So here's a decision tree model. So what does this mean? Okay, if you look at this model, what does it mean? Okay, let me explain it to you. So here is our first node. Okay, now here's how you read it. NA to K, if NA to K is less than or equal to 14.615, then you take the leaf on the left, okay? However, if your NA to K is greater than 14.615, then you take the leaf on the right. And if the patient's NA to K is greater than 14.615, then the patient should take drug Y, okay? Definitely. So that's a prediction that you're making, that if the patient Na to K is greater than 14.615, then the patient should take drug Y. Now, if the patient Na to K is less than or equal to 14.615 and the blood pressure is less than zero point 0.5, then you move on to a next leaf, which is the age. Now, if the patient age is less than 50.5, then you take the next left leaf, then that patient should take drug A. Now, let's go back to blood pressure. If blood pressure is higher than zero point 0.5, then you go to the leaf on the right. Now, if the patient cholesterol level is actually higher than zero point 0.5, then that patient should take drug X. Now, if that patient cholesterol level is less than or equal to zero point 0.5, you go to blood pressure. If the blood pressure is less than 1.5, then that patient should take drug C. If that patient blood pressure is higher than 1.5, then that patient should take drug X. Okay, so that's how you read this decision tree algorithm model. You go at each node, each leaf, and make a decision based on the patient's demographics and information. And then you decide what kind of drug that patient should be taking. All right, everybody, that's the end of this lesson. I want to first thank you. Thank you very much for watching this video. I hope this video has been very helpful to you guys. And again, I want you to get a job pay raise. I want you to get a promotion, apply this knowledge to your job, and I want you to honestly uh, becoming a machine learning engineer. This is the first video in a series of machine learning lessons that I'm going to be doing. And at the end of these lessons, you will be a machine learning engineer. I promise you that. You will be an expert in all these machine learning algorithms. So that's our code. I wish everybody the best. Please subscribe to my channel. Please hit like. And if you have questions or comments, please write them below in the comment section. I wish you all the best. Take care.